Good afternoon, fifth grade friends, and welcome back. I am Mrs. Matani, and I'm so excited that you joined us today. If you can remember, on Monday, we baked a pizza, and I actually did take that pizza home, and I had my children bake it with me at home, and then they ate it that night for dinner. So I actually was able to talk to them about all the ingredients that I put on there, and we talked about fractions while we ate our pizza for dinner. I hope you've had a good week, and so today we're going to move forward. When we did our lesson on Monday, we were adding fractions, simplifying fractions, and we got into multiplying fractions as well. And so today, that's exactly what we're going to do. Now, as a reminder, you've already done fractions this school year, and so this is a really great way to review. But fractions are so important in sixth grade. So that's why we decided to make sure we end on fractions to make sure that you are ready for sixth grade. All right, let's take a look. We're going to multiply a fraction by a fraction or a fraction by a whole number. And remember our math terms: denominator, of course, that bottom number, numerator, equivalent fraction, a number line. That's one of the strategies you can use to not only add and subtract fractions, but also to multiply fractions. Area model, we're going to look at that today. Simplify, remember Ms. Matani says you never use the word reduce. Product, because we're multiplying. And then estimate, or an estimate, and your benchmark. And that's really important when we multiply fractions, to have a good benchmark, okay? All right, so every single lesson, we start off with checking our exit ticket from our class before. On Monday, I asked you to multiply the following. Now look at the first one. It says half of 18. Now, just by looking at that, is the product going to be greater than 18, less than 18, or equivalent to 18? It should be less than 18, right? Because you're taking a fraction or a part of 18. And in this case, half of 18 is 9. Yeah. But if we were going to do the standard way to multiply a fraction by a whole number, we would simply have 1/2 times 18 over 1. Remember, 18 over 1 is 18, because 18 divided by 1 is 18. And when you do your standard multiplication, you have 18 halves, or 18 over 2. 18 divided by 2 is 9. So half of 18 is 9, and you probably already know that anyway, because 9 doubled is 18. Now the next one is a little bit more difficult because it's not using numbers that are compatible, which means where you can notice it right away. But I want you to again look, and let's do a little benchmarking before we move on. 3/4 of 6. Now I want you to think about that. Do you know what half of 6 is? Half of 6 is 3. So 2/4 of 6 is 3. So 3/4 of 6, is it going to be less than 6, greater than 6, or equivalent to 6? It should be less than. So let's see. If 2/4 of 6 is 3 and 4/4 of 6 is 6, then it's got to be between 3 and 6. So we're going to use our standard multiplication. We're going to say the numerator times the numerator. 3 times 6 is 18, and then 4 times 1 is 4. 18/4, or 18 divided by 4. Now, if I know my multiplication facts, which you should in fifth grade, I know that 4 times 4 is 16, and I also know that 4 times 5 is 20. So I'm going to go with 4 times 4, which is 16, and then you'll have 2 left over to make 2/4. When I see 2/4, can I make that more simple? Yeah, 2 is half of 4, so our product is actually 4 and 1/4. Now remember when we benchmarked at the beginning? I said that 2/4 or half of 6 is 3, and 4/4 or 1 of 6 is 6, so that our product had to be between 3 and 6. Is 4.5 between 3 and 6? Yes. So that's another way that you realize and know that you did it correct. So I hope that checking your exit ticket, I hope you got the same products that I did. All right, moving forward. Take a look at our brain teaser. Look what it says. It says to multiply those, but I want you to try your best to multiply those fractions mentally without doing standard multiplication. Can you do that? I think you can. At least one of them I know you can. All right, half of 22. If you take 22 and divide it by 2, you should get 11. Yeah, because when I double 11, 11 added to 11 makes 22, and so 11 times 2 is 22, so half of 22 is 11. What about 1/4 of 20? In my brain, I start to think about 20 objects. And I think if I broke those objects into 4 groups, how many objects would be in one of the 4 groups? Well, if you know your multiplication facts, you should be automatically able to say, I know 4 times 5 is 20. So 1/4 of 20 should be 5. Let's see though if I'm right. Now that I am going to do this standard, because I did it mentally, but I talked it through, 1/4 of 20. Remember, 20 over 1 is the same thing as 20, because 20 divided by 1 is 20. And when you go straight across, you have 20/4 or 20 divided by 4. And what is 20 divided by 4? Yep, it's 5. All right, so how'd you do on the brain teaser? Pretty good. Those were not too hard. And I wanted to start off like that because I'm going to take this last fraction here, this last problem, 1/4 of 20, and I'm going to move further with it, okay? So let's take a look at multiplying a fraction by a whole number. The last slide, our brain teaser, said 1/4 of 20. Now take a look. It says 2/4 of 20. So if you're thinking about breaking groups of 20 into groups of 4, and we said that one group of 4 had 5 objects, what would 2 groups of 4 have? Yeah, it would have 10. Also though, 2/4 is a half, and half of 20 is 10. So I'm going to write that there. So if we knew that 1/4 was 5, 2/4 was 10, do you think you can know what 3/4 of 20 is without solving it standard? Again, 1/4 is 5, 2/4 is 10, 3/4 is, yeah, 15. If we were to keep going, 4/4 of 20 should be 20, because 4/4 is 1 whole, and 1 times 20 is 20. Now look at the next fraction I have, 5/4 of 20. Think about 5/4. Look at the numerator and look at the denominator. Do you notice something? You should notice that the numerator is larger than the denominator. That's called an improper fraction, right? But we can still multiply this mentally if we just think about patterns. Now remember, when we benchmark and do estimation, we think about numbers and what they mean and where we can place numbers on number lines or in our head mentally. And if we know that 3/4 of 20 is 15 and 4/4 of 20 is 20, and the pattern was 5, 10, 15, 20, what do you think 5/4 of 20 would be? It's over 1, so it has to be more than 20 because it's not 1 times 20. It would be 1 1/4 times 20. What do you think it is? If you said 25, you are correct. Each group of fourths goes up by 5. So one group of 4 was 5. 2 groups was 10. 5, 10. 3 groups was 15. 4 groups was 20. 5 groups of the 5 would be 25. So 5/4 is more than 1 whole. So we would benchmark that our number would be more than 20, and it is. 5/4 of 20 is actually 25. So when you see multiplying mixed numbers times whole numbers, it's not as hard as you think if you leave it like this. So this right here actually is 1 1/4 times 20. And that looks harder to me as a teacher, as a person. That makes me kind of nervous, and I look at that and think, I don't know how to do that. But if you have this as an improper fraction of 5/4, because here's 4/4, that 1 whole is 4/4, and another 1/4 is 5/4, then it's easier to go straight across and multiply an improper fraction times the whole number instead of the mixed number. All right, another way that we can multiply fractions is by using a number line. Now this right here is a ruler, but what's cool about that is we all know by now that rulers are number lines, aren't they? Yeah. So let's look at this. It says shade and label half of a 3-inch section of the ruler. So when I hear that, and I'm going to erase this right here so it's not on our ruler, but when I hear that, I hear half of 3. I'm going to go ahead and put that in my mind as half of 3. Half of 3 looks just like that because 3/1 is 3. Then I'm going to benchmark in my head. And I know that half of something is making it smaller. It's a smaller part of it. So I know that my product will be less than 3. So let's take a look at our ruler. It says to shade and label half of a 3-inch section. Now, I tried to confuse you and I tried to trick you because this ruler here goes all the way up to 4. But remember, number lines are infinite. They go on forever. So we're just going to look at a specific spot on the number line. I'm going to start my number line at 0. There's our 0. And I'm going to end at 3. So now, looking at half of 3, look at this number line, and can you visually see where half of 3 is? Half of 3 is right there. That's the halfway mark, half of 3. So if I look, this is 1 inch, and that's halfway to 2. So I should say that half of 3 inches is 1.5 inches. Let's see if I'm right, okay? Now we'll do 1/2 times 3, standard multiplication. Going straight across. 3 halves. 3 halves. If I'm looking here, there's a half, there's another half, there's another half. There's 3 halves right there. Halfway to 1, halfway, now we have 1, and halfway. There's our 3 halves. 3 divided by 2 is 1.5. There we go. So we can use standard multiplication. We can use number lines. We can also use our minds, mental math, and look for patterns, right? Look for patterns. All right, let's look at another way to multiply a fraction by a whole number. Now, let's look at these tiles here. I have 15 tiles. And there are 3 different colors. There's green tiles, there's red tiles, and there's blue tiles. And I want to find out how many of each color I have. So my total is 15. If 1/5 of the 15 tiles are green, how many of these tiles are green? I'm going to write the problem and I want you to solve this. You might be able to solve it mentally, or you might use the tiles here, or you might use standard multiplication. So green tiles, it said 1/5 of the 15 tiles are green. One-fifth of 15 is 3, yeah. So here's green tiles right here. Those 3 right there are green. Okay, so now I have 12 more tiles that I have to color in, but I'm still going to use the number 15 because that's my total, that's my entire whole, okay? Now it says 2/3 of the tiles are red. So I will write that down. 2/3 of the 15 tiles are red. Now this one is a little bit harder because you don't have a 1 as the numerator. But take a look. Think about what I said. Think about benchmarking. Think about 3/3. 3/3 is a whole, and this is 2/3. So it'll almost be 15 tiles. Not quite though. Can you figure out how many red tiles there are? 2 times 15 is 30, and 3 times 1 is 3. And so 30 divided by 3 is 10. Yeah, so there are 10 red tiles. Now there were already 3 green, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tiles are red. 2, 4, 6, 8, 10. And it says the remaining tiles are blue. Well, how many tiles do you see that are remaining? Yes, 2 tiles out of the 15 are blue. So because I worked out the problem of green tiles and red tiles, I was able to see that there are 2 blue tiles left, okay? And this actually is a really fun game that I have in my classroom that I use each year with my students. And they have different colored tiles, and they have different cards, and they have all sorts of different scenarios with their tiles. Your teachers actually may have this game as well. It's one of my favorite games to play. All right, now we're going to move on to multiplying a fraction by a fraction. Now again, what's easy about this is there is the standard way to multiply. Super simple. But there's also modeling, and I always find it important to show different strategies and models so that you can truly understand what it means. So let's take a look. It says shade the area model to show 2/5 of 2/3. Now, of course, our standard is 2/5 of, that means to multiply, right, 2/3. That's our standard way. But if I had an area model, I want you to take a look. I always build my area model based on the second fraction because this is the part of what I'm looking at. So I built this area model, and the first thing I did, I'm going to draw it and then I'll erase it. But here's my model, and I broke it into thirds. Do you see right here? There's the thirds. 1, 2, 3. And 2 of those thirds are shaded. So I could shade in 1, 2. And that's what I would do here as well. There they are. There's my 2/3. Does that make sense? Then I would take 2/5 of those 2/3. And I'm no longer going to go down my model. I'm going to go sideways. If you think about the word area in math, it's your length times width. So here we did down, so now we're going to turn sideways. And so now it's in fifths. Now they look the same, don't they? So I went thirds going down, and then I take my pencil and I use the same model and I turn sideways to show my 2/5. Now, this is the hard part. You have to shade in 2 sections of the 5. I'm going to try that in red. This is section 1 and this is section 2. 2 sections of the 5. Now we're going to count. The first thing we're going to do to get our denominator is we're going to count all the boxes we see. Now again, this I just kind of created. Let's look at this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have a total of 15 boxes. And so 15 is my denominator. How many boxes in the area model have both blue and red? 1, 2, 3, 4. And I know that's hard to see, but there's 4 boxes that have both blue and red. That is my numerator. Now, let's see if we get the same answer using the standard way of multiplying fractions. 2 times 2 is 4, and 5 times 3, is 15. Do we have the same answer, the same product? Absolutely. So area model is really great to show you the why, what it looks like, and then this is the fast way to do it. Notice that 4/15 is much smaller than 2/3 and 2/5. When you multiply a fraction by a fraction, your product is going to be smaller than those 2 fractions, unless those 2 fractions are improper. They have a higher numerator than denominator. All right, let's look here and let's try to figure out what 2 fractions were used to multiply by looking at the area model. I'm going to go down the model first. Row 1, 2, 3, 4, 5. So that denominator is 5. And then I'm going to look right here to see how many are shaded in. 1, 2, 3, 4, 5, 6. Oh, sorry, 2 rows. Sorry, 1, 2, 3 across shaded in. All right, now let's turn and go sideways. 1, 2, 3, 4, 5. All right, so it looks like I should have 25 squares. Look and see. 5, 10, 15, 20, 25. Yeah. And then these 3 down were shaded. 3. How many were shaded across? 2. Yeah. How many have both colors? 1, 2, 3, 4, 5, 6. 6 have both colors. So we have 6 25ths. Yeah, there you go. All right, take a look at this one. It says 5, 6, 7 hour, and 4/5 of that time was spent doing something else, okay? And I'm not going to read the entire part because I'm starting to run out of time. If we did standard multiplication, we could say 5/6 times 4/5. 5 times 4 is 20. 6 times 5 is 30. 20/30. Can I make that more simple? Yeah, I can. And if I were to make this as simple as possible, it would become 2/3. 2/3 of the time. Good job. Our exit ticket for today, and I'm going to check it on Monday, half of 3/5 and 3/4 of 6/5. Again, 6/5 is an improper fraction, so think about that. Half of 3/5 and 3/4 of 6/5. Let's see what you can do. Thank you so much, my friends. Remember, if you need me, you can call or email. And remember that you are so much closer to being a 6th grader. I'm so proud of you. Thank you.